Okay, so before we even look at this parallel line craziness, let's see what we see with just this line, right? So if this is a 60-degree angle here, looks about 60, right? Short of 90. What you first want to think of is how much you'd have to add to that. How much would I have to make this angle bigger by to make a full straight angle? So we know that there are key ideas, that there are 180 degrees in a straight angle. And that makes sense. Picture we're pretty comfy with like, that's 20 degrees-ish, right? Make it bigger until we get to 90, right? Perfect book corner straight right angle. And then if we keep making that bigger by another 90, it falls flat. So the 90 plus 90 gives you that straight angle, 180 degrees. So if I'm at 60, how much more do I need to add to get to 180? Well, that's 120. So if this angle's over there is 60, then that angle there is 120. And they are what we call, the fancy word is supplementary. Angles that add up to 180 are supplementary. So it turns out that every angle in this diagram is either a 60 or a 120. It either equals a 60 or it equals 120. Let's actually get rid of this again. I don't want to look at that. But we can do the same reasoning to figure out, look at this straight angle. And you're like, I've got 60 degrees. How much more do I need to get to 180? And you're like, 120. And it turns out that we call these vertical angles. When you have two lines that cross, you make two sets of vertical angles. This one will always be equal to that one, and this one will always be equal to that one. And we call those vertical angles. So fancy term is vertical angles are congruent, basically just meaning that they have the same measure. Basically, they're equal to each other. So if you hear me say congruent, that's what I mean, basically that they are equal. And so so that's 120. And then we can do the same reasoning with this straight line here. So if I've got 120 degrees, how much more do I add to it to get that straight angle? That's a 60. And hey, look, those vertical angles are congruent. So we went really slow through that. But basically, it's like, okay, well, you're either a 60, and then this guy's vertical to that, so that's 60. Or if you're not equal to it, like this guy here is clearly obtuse, you're supplementary to it, and you're 120s. Cool. So now, when we put in a parallel line, one underneath it, so now if we have a parallel line down there, turns out you just kind of want to transpose these guys down to those guys. If I could do this nice, I would. Oops. Can I move it? Oh, yeah. So all of those angles up there correspond to those angles down there. If the lines are parallel. Only works if the lines are parallel. It'll say in the directions, or it'll mark the diagram with these little parallel lines. So if the diagrams all are parallel, all these corresponding angles are congruent. So if that was that, maybe I can copy and then scoot them down, paste. Oh, that didn't work. But anyway, so this angle corresponds to that angle. So that's 120. This one corresponds to that one. And there you go. So we've labeled every single picture in the diagram. So when we say corresponding angles, I think when I first learned these in geometry, I was too, my English wasn't strong enough, and I didn't really quite understand what that word meant. And it makes sense to me now. It's like, oh, this 60 degrees is in the same position. It corresponds to that one. They're in the same upper right corner, if you were to say. And so all those corresponding angles are going to be congruent. So corresponding angles are congruent. So I walked through that one very slowly, and then we're going to walk through the next ones more quickly. So there we go.